the first woman in the world to receive the Nobel Prize for her pioneering research on the phenomenon of natural radioactivity, which became the basis for many other groundbreaking works on matter and its transformations. The first researcher to receive this award twice in different disciplines. It is thanks to her that women finally gained access to all levels of scientific development and could be recognized for their achievements. Marie Skłodowska-Curie, voted the most influential woman in history by the BBC History's poll, was born on November the 7th, 1867, in Warsaw. The building at 16 Freitas Street, where she was born, now houses her biographical museum and the Polish Chemical Society. For several years, she lived with her family on Nowolipki Street, today hosting a magnificent mural by Swansky, which reminds us of the famous inhabitant of Muranów district. On the bank of the Vistula River, where Skłodowska liked to walk in her youth, there is a sculpture of her by Bronisław Krzysztof. Next to it, there are benches where you can sit and admire the wonderful multimedia fountain complex, the river, and the panorama of the Prague district. After graduating with honors from secondary school, she attended classes at the Flying University, an underground Warsaw university. Workshops were held at the Museum of Industry and Agriculture. In the annex at the back of the building, a chemical laboratory was set up, where 23-year-old Marie, thanks to the kindness of her cousin who was in charge of the institution, was able to conduct her first experiments and master the basics of chemical analysis, including the analysis of minerals and water. Years later, Skłodowska admitted, "If I hadn't been taught chemical analysis well in Warsaw, I wouldn't have isolated radium." Despite her great attachment to her hometown, which she often emphasized in her speeches, Skłodowska decided to leave the Kingdom of Poland, which was then under 3 partitions, in order to be able to continue her studies. Warsaw belonged to the Russian partition, where women were not allowed to enter universities. In 1891, she went to Paris, where she enrolled in the Faculty of Physics and Chemistry at the Sorbonne. During her studies, she met the scientist Pierre Curie, whom she married in a registry office in 1895. At the time, Skłodowska was mainly concerned with the magnetic properties of steel, while her husband was a respected expert in the field of magnetism. However, Marie changed her focus and began pioneering research on the invisible rays emitted by uranium, a phenomenon recently discovered by Professor Henri Becquerel. Marie Skłodowska-Curie's first PhD research showed that some uranium ores, such as pitchblende and torbanite, radiate much more strongly than the pure uranium obtained from them. At that time, she put forward the bold hypothesis that the main source of radiation was neither uranium nor its compounds, but a so far unknown substance, accompanying them in minimal amounts. She therefore focused her further research on separating it from minerals. Using tons of available uranium ores, utilizing contemporary chemical analysis techniques. The hypothesis put forward by Marie was so sensational and promising that her husband joined her work, interrupting his own research. Mr. and Mrs. Curie isolated from uranium ore 2 new chemical elements. One of these they called polonium to commemorate the then occupied homeland of Marie. The second element they called radium, from the Latin word radius. Marie Skłodowska-Curie called the phenomenon of spontaneous emission of radiation by chemical elements radioactivity, and was the first to hypothesize that it is a natural phenomenon derived from the atoms of certain elements, the so-called radioactive elements, that are present in nature. Soon, these discoveries gained enormous publicity and recognition. On October 12, 1903, the Royal Swedish Academy of Sciences awarded the Nobel Prize in Physics to Henri Becquerel and Mr. and Mrs. Curie for their research on the phenomenon of natural radioactivity. Everything was going almost perfectly. And it was then, 3 years after receiving the prize, that Pierre died tragically in a street accident. Marie, plunged into great despair after the loss of her beloved husband, did not stop her intense work. In 1911, her determination and steadfast commitment were honored with a second Nobel Prize, this time in chemistry, for her discovery of polonium and radium, and for her research on metallic radium and its compounds. Soon after, the Sorbonne founded the Radium Institute, an innovative center for scientific research on radioactive elements and the applications of radioactivity in cancer biology and therapy. Their sensational discoveries aroused great interest and recognition in scientific circles, also in Italy, as evidenced by the awarding of the Matteucci Medal by the Italian Academy of Sciences in 1904. Many articles and studies have been devoted to the radioactivity of metals, minerals, volcanic products, thermal waters, gaseous emissions, and muds. These publications brought the researcher to the attention of the Institute of the Academy of Sciences in Bologna, which in 1909 appointed her a corresponding member of the section of Physical and Mathematical Sciences. Despite the great interest in the phenomenon of radioactivity and repeated attempts to organize the trip by Professor Vito Volterra, an eminent mathematician and physicist, as well as the head of the Bureau of Inventions and Research in Rome, the future National Research Council, CNR, with whom she had already established a relationship based on mutual respect and friendship, Madame Curie did not arrive in Italy until 1918. At the end of the First World War, France began to run out of radium, which was also used in field hospitals. For this reason, Madame Curie decided to visit the Italian thermal springs, which were the source of the emanation of this element, which could be transported quickly and without any hindrance to France. At that time, preliminary research on natural radioactive substances was already being carried out in Italy. The problem was their isolation and practical use. Hence, the goal of the mission was to confirm the previous discoveries of Italian scientists, find new sources of these elements, and determine the ways of their extraction and use. Madame Curie arrived alone from Paris to Pisa by train on July 30th, 1918, at 3:30 a.m. Why did Skłodowska-Curie arrive specifically in Pisa? Let's ask Professor Lorenzo Di Bari about that. Professor Curie came to Pisa at the invitation of Raffaello Nassini, professor of chemistry at the university, who was also famous abroad for his study on the waters and thermal springs so abundant in Tuscany. The purpose of Nassini's invitation was to investigate the radioactivity of both local sources and some of the thermal baths or mines he had identified throughout the peninsula, in search of minerals that would allow for obtaining of radium, an element that she had discovered and which remained at the center of her scientific interest, not only in the context of basic research, but also in the context of its applications in medicine. Here in Pisa, Professor Skłodowska-Curie also met Nassini's young assistant, Camillo Polezza, who later became a professor of chemistry, the successor of his master. The first task was to test the equipment provided by the University of Pisa for the research mission. After confirming that it was indeed perfectly suited to the planned measurements, together with Polezza, they embarked on a long journey in which they traveled more than 3,000 kilometers in just 3 weeks, arriving at places that even today remain difficult to reach, showing commitment, diligence, and I would even say total devotion to the research they carried out. Madame Curie spent her first days on intense research in Tuscany. First, she visited Bani di San Giuliano, just a few kilometers from Pisa, to test the available equipment on site. The exceptional radioactivity of the local spring waters had been the subject of analysis for several years. Thus, it was a good starting point for the measurements. Fortunately, any doubts were dispelled. The Pisan instruments did not disappoint. They worked flawlessly. From there, the Nobel Prize winner was finally able to embark on a proper scientific and research tour in search of further potential sources of radioactive substances. Polezza, who accompanied her at every stage of the journey, took samples, which were then analyzed in Pisa. On August the 1st, she arrived in Bani di Montecatini, the waters of which were famous for their beneficial properties to the liver and the intestines. Together with Camillo Polezza and Raffaello Nassini, she measured the radioactivity of the medicinal waters in Tetuccio. On the 100th anniversary of the researcher's birthday, Polish Academy of Sciences, on the initiative of its scientific center in Rome and the Montecatini Terme municipality, placed a marble plaque that commemorates that visit. Skłodowska-Curie stayed at the Grand Hotel La Pace, then one of the most famous hotels in Italy. Today, thanks in part to the visit of the Polish Nobel laureate and her research on radioactivity, Montecatini is one of the most famous European thermal resorts. The last stage of the visit to Tuscany was Larderello in the province of Pisa, a town known for its peculiar landscape, filled with columns of white vapors, testifying to the presence of boric acid fumaroles. These natural phenomena, already known in the time of Dante Alighieri, inspired the poet to describe the scenery of hell. After the founding of the spa and the subsequent period of development and revival, Larderello became the world's first geothermal power plant. It was here, for the first time in history, that man generated electricity using heat from the Earth's core. At Larderello, Marie Skłodowska-Curie worked in the company of Raffaello Nassini, professor of chemistry at the University of Pisa, and above all, a great expert in boric acid exhalations. Together they measured radioactivity of the gases coming out of the fumaroles. In addition, Nassini informed her in detail about his current research and plans for the industrial use of the gases escaping from below ground. In this place, the memory of the visit of the great Polish scientist is still alive, and today the Museum of Geothermal Energy is located here. Then the research crew moved to the south of the country, beginning the second stage of their journey. Due to the ongoing war, the Nobel Prize winner's research tour took place without fanfare. From bombarded Naples, Madame Curie headed to Ischia, aboard a torpedo boat of the Department of Maritime Affairs, to measure the radioactivity of the waters in various corners of the island, known for centuries for their therapeutic properties. In Lago Ameno, she explored the waters of the Regina Isabella Spa, where her work is commemorated by another plaque, placed under the portico of the building, on the initiative of Camillo Polezza 40 years later. The island turned out to be a place particularly rich in the radioactive emanations of radium, coming not only from the waters, but also from the soil and even the air. Today, it is home to one of the world's leading spas and resorts. The researchers then traveled to the island of Capri to collect more samples. The research tour was strictly of a working nature, and Madame Curie insisted that she had come here for scientific reasons and that she would make a tourist trip on another occasion. Eventually, however, she yielded to persuasion, although not without reluctance, to visit the Blue Grotto. On their way back north, they stopped at the Eternal City, where Madame Curie met Professor Orso Mario Corbino, a famous physicist, politician, and director of the Institute of Experimental Physics at the University of Rome. Next, they traveled by train to Padua, a city particularly dear to the Polish people. Thus began the third stage of the research tour of Italy. Here, Madame Curie visited military X-ray laboratories, comparing them with those she had founded in France. During the visit, she expressed her appreciation for the organization of the facilities, recalling how much work she had to do herself to create similar structures. In Veneto, the team of scientists visited the beautiful thermal springs of Urbano, Battaglia, and Monte Grotto, and verified the radioactivity measurements taken there earlier. The packed itinerary also included a short cruise aboard a motorboat from Fusina to Venice. Despite some hesitation on the part of Madame Curie, as Polezza wrote, "We managed to overcome her resistance and show her the beauty of this fascinating city on the lagoon." Soon after, the team set off for Piedmont, where, under the scorching August sun of Lurecia, the scientist not only studied the very strong emanation of radon from the Nivellano spring, but also took samples of autunite, which she took with her to France to check the amount of radium it contained and assess the possibilities of extracting it. Skłodowska-Curie searched for this precious element all over Italy and found it only in the caverns of the Lurecia quarries. It was there, after examining the rocks with instruments from the University of Pisa, which, according to the memories of one of the local assistants, were boiling, that Madame Curie uttered the famous words in French, "A lot of radium." The assistant received a tip of 3 lire from the Nobel laureate, which was a fortune at the time, as a thank you for the help in the measurements. Today, the cave is named after the scientist. After her visit, a spa was built there, the waters of which are highly valued for their health benefits. Alessandro Ivanizzi, who introduced the Lurecia water and beverages to the international market, stated, "The figure of Madame Curie is closely linked to the roots of Lurecia and is a symbol with which we identify 3 fundamental values. First, knowledge. She was an outstanding scientist, making the pursuit of knowledge the goal of her life. The second value is based on her indomitable character. She was a woman of great strength. Finally, she was a citizen of the world. Born in Poland, she lived in France, where she studied and established herself through scientific research." The research tour ended on August the 18th in Sanremo, with the collection and preliminary summary of the measurement results. The next day, scientists escorted the Nobel Prize winner to the railway station in Ventimiglia, from where she returned by train to France. Madame Curie soon sent an official report on the mission to Professor Volterra, along with a letter in which she thanked him for Italian hospitality. The research tour also made an important contribution to the creation of the Italian National Commission for Radioactive Substances, created in 1919, which later proved to be decisive for the scientific work of a group of physicists led by Enrico Fermi. In the letter, the Commission thanked the scientist for her contribution to the study of Italian sources and deposits of radioactive substances, and for her valuable advice, looking forward to further cooperation with the Curie Laboratory and the French Commission for Radium. Since then, Italian scientists and the Radium Institute in Paris have established closer scientific contacts. Already in October the same year, Polezza, Volterra, and Nassini visited the Curie Laboratory and the French factories producing radioactive samples. A year later, Madame Curie sent a letter to Polezza, now kept at the Faculty of Chemistry and Industrial Chemistry of the University of Pisa, attaching a sample of the standard radium chloride for standardizing measurements of radioactivity in spring waters. The memory of this journey has always remained alive in the academic community, especially here in Pisa, and above all in the Faculty of Chemistry. Consider that when I was myself a student of chemistry, I looked with a kind of reverence at the pages of correspondence between Curie and Polezza, preserved at our faculty. Returning to Warsaw, the Stasi's Palace, currently the seat of several institutes of the Polish Academy of Sciences and the Warsaw Scientific Society, was where in 1925 Madame Curie gave a lecture on the functioning of the Radium Institute in Paris, which she founded. At that time, the Nobel laureate pointed out the need to create a similar institution in Poland. Another place associated with her is the tenement house at Śniadecki Street, the seat of the first radiological laboratory in Poland, where Skłodowska-Curie became the honorary director. On Wawelska Street, only 2 years before her death, one of her greatest dreams came true. The Radium Institute was established, the first modern cancer center in the independent Poland. During the inauguration ceremony, the renowned scientist presented the institute with the first gram of radium, funded by Polish women living in America and given to her by the President of the United States, Herbert Hoover. This event was also commemorated on the opening day by the Nobel laureate planting a tree of remembrance of the sycamore maple Marie, which still grows in the garden next to the building. Beyond the fence there is a street named after Marie Skłodowska-Curie, and in the nearby park, created in the mid-30s, there is a statue of her. Let us remember that the contemporary fight against cancer in the world began with two epochal discoveries, Röntgen's X-rays and the Polish scientists' radium and polonium. Today, the building belongs to the National Institute of Oncology, named after her, which is the largest such facility in Poland. In 1944, the International Union of Pure and Applied Chemistry named the newly discovered element curium in honor of the Curies and their breakthroughs, the effects of which changed the course of our civilization, affected the quality of life, and saved countless people. The element curium will always be a reminder of the indomitable determination and passion of these extraordinary scientists, whose biography is and will be a great source of inspiration to many. Marie Skłodowska-Curie visited a number of countries. Regardless of national borders, her accomplishments are meaningful not only for Poland or France, but they have become a great benefit for all humanity. Her journey to Italy demonstrates that science knows no boundaries. It needs a free flow of ideas, open discussion, and collaborative effort. While Skłodowska's research revolutionized our understanding of physics and chemistry, providing scientists the tools to save human lives, her actions were motivated by profound respect towards life as such. Her study tour in 1918 and the subsequent scientific and practical achievements constitute a fine example of such an approach.